Hello everyone and welcome back to this series of digital logic design, and today we will study canonical form of product of Maxterms. To express a Boolean function as a product of Maxterm, it must be brought to a form which consists of OR terms. Here OR terms means that all the variables within the terms are being added, and this may be done using distributive law, which says that x plus y dot z equals x plus y into x plus z. Here in the original function consists of two terms. First term have a single variable and the other term have two variables which are being multiplied. Now for changing it into OR terms, we will use distributive law, and results in x plus y into x plus z. Again here we have two terms, and in the individual terms two variables or literals are being added. After this, we will look for any missing variable. If the given function consists of overall three variables, then in every OR term there must be three variables, either in the prime form or the unprime form. If any of the variable is missing, then that will be introduced using Boolean algebra rules, and the procedure is further clarified in the upcoming example. Now we have a given function f, and we have to express this function as a product of Maxterm, where the function consists of sum of n terms. The overall function consists of three variables x, y and z, and two n terms are being added. As a first step, we will change these n terms into OR terms, and for this we will use distributive law. So applying distributive law and using rules of Boolean algebra, we will have function f equals to x prime plus y into x plus z into y plus z. Now we know that the function overall consists of three variables, and for canonical form it is required that all the terms must consist of all the variables. So within each term one variable is being missing. So we will introduce the missing term by using the rules of Boolean algebra. Now if you look at the first term, which is x prime plus y. Now in this term variable z is missing. So we will use the rule that adding 0 won't affect the overall equation, and this 0 can be replaced by product of z dot z prime, which is the missing variable. And further using the distributive law, we will have two terms. First one is x prime plus y plus z, and second one is x prime plus y plus z prime. And the same steps will be repeated for other two terms, and the missing variable will be introduced. And further, if you observe every term, you will identify the repeated terms. Now we will combine all the terms and remove all those terms which are repeated, and we will have a function which will be in the form of product of Maxterms, or we can replace the Maxterms with their designations. So f will be equal to product of m0, m2, m4 and m5. A more convenient way to express the function which consists of product of Maxterms is using product sign, which says that function f of variable x, y, z equals pi with numbers 0, 2, 4 and 5. Here the pi symbols represents multiplication or product, and the numbers followed by the product sign indicates the terms which are being multiplied, and the function variable f represents output followed by a list of variables x, y and z, which represents input variables. Now a Boolean function can be converted from an algebraic expression to a product of Maxterm form using the truth table, like in previous case, as we have converted a Boolean function from an algebraic expression to a sum of minterms form. Now consider the same Boolean function, which is x dot y plus x prime dot z. The function consists of overall three variables, so we will derive a truth table of the function, which will have total of 8 binary combination, and for all the binary combinations we will compute the output. Now we will look for the output function, and will identify those binary combinations for which function have a value of 0. Now if you look at the table, the first binary combination of 0, 0, 0 have an output value of 0. Then for 0, 1, 0 output is 0. Similarly for 1, 0, 0 and for 1, 0, 1 the output is 0. So for these binary combinations we will form Maxterms. For first combination of 0, 0, 0 the Maxterm will be x plus y plus z. For 0, 1, 0 the Maxterm will be x plus y prime plus z. For 1, 0, 0 the Maxterm will be x prime plus y plus z, and similarly for 1, 0, 1 the Maxterm will be x prime plus y plus z prime. Now we will combine all these OR terms using multiplication, and we will have a function which will be in the form of product of Maxterms. Or we can replace these Maxterms with their corresponding designations, or can use a simplified form which says that function f of input variables x, y, z equals to the product of the Maxterms of designation 0, 2, 4 and 5. Now we will study complement of a function using canonical form. Like earlier we studied, if we have a function which consists of sum of minterms, and if we wish to find complement of the same function, then it will consist of sum of minterms which were missing in the original function. Like if we have a 3 variable function, then we have possibility of 8 binary combinations. And if function f consists of 5 minterms and corresponding to each minterm the function have an output value of 1. Now its complement will consist of all those minterms which will have a value of 0, and the number of minterms will be 3. Now consider the example in which the function consists of 3 variables a, b and c, and the corresponding minterms which makes the output of 1 are 1, 4, 5, 6 and 7. Now the function has a complement that can be expressed as f prime of variable a, b and c will be equal to sum of 0, 2 and third minterm, or the sum of m0, m2 and m3. Now if we take complement of the f prime and solving using De Morgan's law, the function f will be equal to product of m0 prime, m2 prime and m3 prime, and we know that the Maxterm with subscript j is a complement of the minterm with the same subscript j. Now substituting, we will have function f equals to product of capital M0, capital M2 and capital M3. The last example demonstrates the conversion between a function expressed in sum of minterm form and its equivalent in product of Maxterm form. Or similar argument will show that the conversion between the product of Maxterm form and the sum of minterms is similar. Now if we state a general rule of conversion, we can make conversion from one canonical form into another by simply interchanging the symbols and list numbers missing from the original form. Or in order to find the missing terms, we must realize that total number of minterms or Maxterm can be 2 power n, where n is the number of binary variables within a function. Thanks for watching the video and stay connected for more interesting videos.